Welcome to Brain Vision.
Okay, the reactions of some alkenes and some alkynes, right? Or more so, we should say, some reactions of alkenes and alkynes proceed with anti-stereochemistry, right? So is there an example that we can think of? Yeah, right off the bat, what I think of is the bromination of an alkene, right? Because usually we get anti-addition of bromine, right? So maybe we could say, if we started with that structure, if we wanted to actually have some sort of stereochemistry to this, right? We'd know that the bromines are going to add anti. Right, and our methyl groups were also anti. Sorry, let's just do this. Right. Why is this? It's not just Br2. It could also be if we've added, say, what's a classic one? HBr in the presence of like methanol. Usually we get anti-addition of bromine and the methoxide, right? Why is this? Why does this happen for some alkynes and alkenes? And you'll notice that for every reaction that it happens for, there's a particular transition state that explains it, right? And that is the following. Okay. So if we've got some alkene and we've got Br2, right? Recall that the double bond opens to attack the bromine at the exact same time that this bromine is attacking the carbon, right? And typically we conceive of this bromine leaving the bromine-bromine bond splitting while that happens, right? So the product of that then is this sort of cyclic intermediate, right? And one way we can draw this to show that these bonds have to be bonds to bromine. You can't have a bond, like imagine you've got a bromine floating here near what used to be your double bond, and one bond is up to it. Well, you can't have a bond down to it, right? They've both got to be up, right? Both the bonds have to be in the same direction to both be bonded to bromine, right? And then, the remainder of this mechanism is that this bromine will then attack one of the carbons, and this bond will release. And recall that, if we've got a wedge here to this bromine, right, then the bond we're forming with this bromine can't be a wedge. It's not attacking from the front. There's no room. It's got to attack from the back, which means that the product we get, we're still going to have this wedge to bromine, but the bromine we just added will have to have come from the back, and so it'll be a dash, right? And so the most, I guess, group of answer choices, blah blah blah. The answer is let's see, reactions to follow there's steric hindrance in the intermediate that prevents attack from the same side. That's the answer. Option 1, 2, 3, 4, 5. Right? That's what we just showed. This intermediate shows us why bromine has to attack from the back. And that's true for, all the other reactions that give us anti-addition, right? So, like I said, that's true for Br2 and methanol, for example. Any sort of reaction that's going to give us an epoxide. And it's true for alkynes as well. So I showed it with an alkene, but you can make the same logic work with an alkyne.